Hi guys! So you know already quite a lot about Dedicated SQL Pool, this good old traditional data warehouse that is available as a part of Synapse Analytics. Today I would like to cover some additional features of Dedicated SQL Pool, like workload management or partitioning. So let's get started. Alright, so let's talk about those extra features that make SQL Pool so nice. So the first thing I wanna talk about is workload management. So let's jump into the whiteboard and let me start describing what this feature is. So workload management. That's the first thing I want to discuss today. Management. All right. So imagine this. This is in the middle. This is our wonderful SQL pool, the one that we designed, the one that contains tables inside, because it's all about tables. Probably it's modeled using star schema or Snowflake if for some reason we decided that Snowflake would be better. And now, how do we handle concurrent queries to this database? And why concurrent? Think of it. So from one side, oh come on, let me change the color to green. So from one side we will have our internal queries, for example the ones that we use to populate our tables with data, those insert statements, update statements. At the same time, we might have some users that want to run some ad hoc queries, some analysis. That's what SQL Pool is used for, to provide data for analysis purposes. So ad hoc queries. Probably we also have some front-end tool that is used to, well, to present the data in a more nice form than just a result of SQL select queries. So we might have Power BI or some other tool that we use for reporting, but let's assume that it is a Power BI. And Power BI also will try to connect to our pool to get the data. So as you can see, we might have multiple principals, multiple entities that want to get access to our data at the same time. We will have this concurrency. So how do we handle this? How do we make sure that each of those requests will be handled in a proper way? How do we ensure that proper number of resources like memory or CPU will be available to every request? And finally, how do we make sure that those queries that we consider more important are handled in the first place? And the answer is, well, that's what workload management is used for, to handle this concurrency. So how does it work? So let me move this to the side. And it is like this. So let's say that we've got someone, whether it's a process, person, some software, that would like to get access to our data. Insert, update, or just select. Doesn't really matter. Basically, that person wants to query the data. And we know that the query is sent to the dedicated SQL pool, to our control node. But then what? How it is handled? So let's assume that this big rectangle is our SQL pool. And what happens under the hood is that our query is being classified. So the first thing that happens whenever a query is submitted is classification. So classification. And classification, well, it simply means that our query is mapped, our request is mapped based on some rules that I will talk about in a second, to a workload groups, basically to some resources that will be used to execute our query. Alright, but workload groups, what are those? So let me add it to our diagram. Those are red rectangles. So we might have multiple workload groups, so those red ones. These are just workload groups. And workload group, well, it is simply a set of resources that we define that are available for a specific set of queries. So basically, it is our job as database designers to think about type of queries that will be run against our database, just how we want them to be categorized. And, well, you can take a look at those categories that we defined at the beginning of this session. So maybe we would define a workload group, a category for our ETL processes. Maybe we'll define a category for our finance department, because we know that those guys from finance, well, they need to have their queries handled in the first place because they are super important and they get very upset if they have to wait for a few seconds to get the results back. Maybe we'll define a workload group for some ad hoc queries that, well, they are not that important and those can wait. So the classification is simply a way to assign our query to one of those workload groups. Alright, but how is this classification designed? How it is happening under the hood? And well, basically you would create something called a classifier, inside which you would define, well, a set of rules based on which this classification would happen. And usually what is used to classify a query is to simply use identity of the principal that is submitting the query. So you might use, for example, a database username that executed the query, or maybe you want to use a database role that this principal has, or maybe you want to use an Entra login, and based on this login, so for example, if it is Piotr, if it is me, then I want to be assigned almost all resources. I want my queries to be executed as fast as possible. Maybe instead of using individual logins, you would like to use Entra groups. Or maybe you would like to classify the queries based on time of a day when they are executed. So for example, you know that during the day, during business hours, these are basically some users running the queries, and at night it is ETL processes that happens. And then maybe based on this, you would assign a different workload group. Alright, so one more time. Classification is simply a mapping a specific request based on some set of rules to resource allocations to those workload groups. Alright, but can you elaborate a bit about those workload groups, what they are? Sure. So let's assume that we would like to create a workload group for finance. But what does it mean to define a workload group? And well, a workload group is simply a way to reserve set of resources that will be available for a particular group of queries for execution. So let's say that we would like to configure this workload group for finance guys, those ones that are impatient and they want their queries to be executed as fast as possible. And workload groups, well, they will allow us to do this. So now, let's assume that this black box is our memory that is available for query execution. And now, when we define a specific workload group, and right now we are doing this for finance department, we can define how much memory will be reserved for this particular workload group, which simply means how much memory will be waiting for queries from finance department to be used for their queries. And let's say we know that they need at least 10% of memory. So what we would do would be like this. All right, so let's set the minimum amount of memory that will be waiting for those finance guys to 10%. And to do this, you would use this fancy min percentage resource parameter when you are creating a workload group. So min percentage resource. And it simply means that no matter what, there will be always at least 10% of the whole memory reserved for this finance workload group. No other process, no other query will be able to use this. No, it will be reserved. So let's mark it like this. So this 10% is reserved, no matter what. But on the other hand, it is just a minimum value. But how about the maximum value of memory that those finance guys can use? And maybe we don't want to grant them all available memory. So maybe you would like to set the limit to 50% of the memory that is available on our SQL pool. And this parameter is called cap percentage resource. Cap percentage resource. All right, so what does it mean? Well, simply it means that for our finance department, there will be always at least 10% of memory waiting for them to be used. They can use more if it is available, no problem, but no more than half of the total memory. So we will leave at least half of the memory for other workload groups. So that's how you can reserve a specific set of resources for a particular resource group. Workload group, not resource group. Now, in case of memory, this is a fixed limit, this cap percentage resource. For CPU, it is more fluid, because for CPU, well, even if we set it to 50%, then if there are no other queries running at the same time, then go ahead, you can use all available CPU power. For memory, it's a fixed limit. You cannot use more than 50%. All right, so this 10% is guaranteed. They can use more if it is available, but at least 10% will be available. All right, but this limit is set for the whole workload group. And what if I have 20 queries from finance running at the same time? Can we set amount of memory and CPU that would be available for every of those queries? And the answer is yes, we can. So let's say that you would like to set 5% of the memory and CPU. Oh, come on, let me change the color to blue one. So, for example, we would like to set amount of memory that is available to every query from our finance department to at least 5%. And you can do this by using this request min resource grant percent. I love those names. And you can see that I'm looking at the documentation because there's no way I would remember those names. Grant percent. grand percent. All right, and now you might think, so if we allow finance guys to use between 10 and % of memory, and each of the queries will use at least 5% of memory, then it might happen then there will be 10 queries running at the same time, right? Because they are allowed to use half of the memory, and each of the queries will use 5%, right? So 50 by 5 equals 10. Not really, it doesn't work that way. Because here, we've got to take this performance level of SQL Pool into account. And performance level, it was this setting, this DW100C and so on, that determined number of compute nodes that we have available. And apart from number of compute nodes, it also determines number of concurrent queries that can be executed at the same time. And if we run into documentation, you will see that in the cheapest option, the one that I'm using right now, this DW100C, there might be only 4 queries running at the same time. So not that much, to be honest. And in this case, this parameter that I was talking about, this request min resource grant percent, well, it will be effectively set to 25%. So, simply put, if you want to have higher concurrency, more queries running at the same time, you have to pay more and buy a more powerful version of SQL Pool. That's how it works. But anyway, those workload groups, well, this is a way to isolate our workloads. It is a way to reserve resources for them. So the important concept, another one in workload management apart from classification, is this workload isolation. So let me write that down. So workload isolation. All right. And workload isolation, well, it is simply about reserving resources for a workload group. All right, so that's how it works. And finally, the third important concept inside workload management is importance. So, all right, we know that our queries are classified to those workload groups. We know that each of those workload groups will have specific amount of resources available. But what if we have, let's say, 4 queries from the finance guys and 4 queries from ETL processes executed at the same time? So which one will be executed first? What is the order of processing? And that's where workload importance comes into the play. So let me explain this. So it is like this. Let me draw another rectangle. Today there will be a lot of rectangles. And what is shown here, it is a scheduler of our dedicated SQL pool. So simply it is a part of the pool that determines which query will be executed as next one. And let's assume that these are the queries. And we have the cheapest version because, well, our budget is limited, so only 4 queries can be executed at the same time. So let's say that these 4 are running right now. But unfortunately, another queries were also submitted, like 5, 6, 7, 8, and 9. But unfortunately, well, they have to wait. They are queued. How do we spell it? Like so. All right, and by default, this scheduler works in a first in, first out first out manner, which means that let's say that query number 2 has finished executing. So let me remove it from the running part. So then the next available query will be executed. In our case, it would be the first one from the queue, which is number 5. So it will jump into the part that executes the query. Great. Then let's say number 4 finished processing, and then it leaves a free spot, free place for the next query, which will be query number 6, and so on and so on. Alright, so let me revert to the initial state. So that's how it was at the beginning. But let's change it a bit. Let's say that query number 7 is super important, and we would like it to be executed in the first place before query number 5 and 6, even though that it was submitted later. And can we do this? Yes, we can. And workload importance, that's the third concept within workload management that can help us with this case. So simply what we would have to do would be to assign a high importance to our workload group. Let's assume that query number 7 is from the workload group that got this high importance. So what happens then? So again, let's assume that query number 2 finished processing, so there is a place for the next query to be executed, but this time scheduler will not pick the next available query from the queue, number 5. No, it will take the next query with the highest priority, which in our case would be query number 7. So query number 7 would be executed before query 5 and 6, and this is importance. So let me write that down. Importance. And importance, well, it is usually defined at the workload group level. So in our case, we might say that, alright, finance guys, they get the highest priority because we know that they cannot wait for the response. But those ad hoc queries, well, they are not that important, so let's give them the lowest priority out there. And when it comes to various levels of importance, well, actually we have 5 levels available. And they are as follows. So in the middle we've got normal, the default one. Then we've got high. We've got low. And we've got the ones in the middle, like above normal, and the last one is below normal. And simply by using one of those importance levels, you can have impact on the way which query is executed as the next one. So to summarize, this workload management that I was talking about is all about determining how concurrent queries will be executed. So first of all, they are classified using our classification classifier that usually works on name of the user who is executing the query, and it assigns a query to one of those workload groups. And there are some workload groups created out of the box, so if you don't create any, there are some. Then within each workload group, you would define amount of resources, CPU and memory, that will be reserved, available for particular queries, min and max. And finally, you can define importance that would determine which queries should be executed in which order. So that's what workload management is all about. All right, so let's move on to the next cool topic that is available within SQL Pool. And the next topic is result set caching. Result set caching. Really cool stuff. And this time I will show you a demo. Alright, so let's jump into Azure portal. I have my pool up and running. And that's my sample script that is executed on my DWH test pool. And right now, well, I have some query. That's the one. It doesn't do anything special. Actually, let me run this. It simply calculates number or a sum of parts per minifig type. And that's the output. Just a regular query, one of those that we might expect to be executed on our pool. And now, if we run this query, you will see that, well, it takes some time to process it. You can see this in the messages tab. This time it took over 3 seconds to return the data. And actually, I don't have that many rows, only 14,000 or so. And if I keep repeating, running the same query, this time it was a little bit over 1 second. The next time, again, a bit over 1 second. Still, not the perfect response time. Especially that nothing has changed in the data. And SQL Pool has just executed this query, so it should know the result. So why it is trying to execute it over and over again? So the way to cache the results of the query is to use this result set caching. And you might see in my query this option label equals to result set caching test. It doesn't do anything, it doesn't change the way this query is executed. It is just used to assign a label to this query, so later on I will be able to find this in various dynamic management views that shows internals of SQL Pool. So let me run this time with this option. And here I have a query. Let me run this. Well, that's the query that goes to this sys dmp dw exec requests view. And simply it shows what requests have been executed. And the column that is important right now is this one, result cache hit, which is set to -1. In this case, -1 simply means that result set caching is not enabled on my SQL Pool. Alright, but what is this result set caching? Well, it is simply a way to cache the results of your queries, so the next time the same query is executed, the pool will not try to run it from scratch. It will just grab the results from the cache, so it would be faster. And by default, it is disabled, so we have to enable this. And it can be done at the session level or for the whole pool. And I will do this for the whole pool by using this alter database statement. But important thing is that it has to be executed on the master database. So let me switch to master. And let me run this alter statement query. And it will take half a minute or so, and I'll be back in a second. Actually, it took only 10 seconds. Anyway, let's switch the database to our DWH test. And let me run our query one more time and see what happens. Alright, data was returned. It took, well, almost 2 seconds this time. And if we check our dynamic management view, and they are sorted descending, so the newest one is on top, you will see that actually result cache hit column is set to 0. So it means that these results of this execution were not taken from the cache because, well, we just enabled this. So the first time the query runs, that's the moment when the results are cached. So if I rerun the query now, it should take the results from cache, so it should be faster. and it is faster, so less than half a second. Still not that great, but at least it's faster than it was originally. And if we check our exec requests view, you will see that this time result cache hit is set to 1, meaning that the last execution, those results were taken from the cache. And if I keep repeating running this query, it will be taken from the cache from now on. And the execution time should be smaller than previously. So simply that's how it works, to cache the data, so it is not executed from scratch every time. Alright, so let me disable this, because I don't actually need this. And to do this, I have to switch to master again. So that's one of the ways to empty the cache or to disable it at all. But you might ask, alright, but when is the cache evicted? Where is this data removed from the cache? So basically it happens automatically every 48 hours, every 2 days, if this result set was not used, or if the data was invalidated. So for example, if our table that is used as a source in this query has changed, if some new data was added to it. So that's first case. Then the cache might be evicted if its size reaches the limit, which is 1 terabyte, I believe. And finally, you can do this manually by running one of the queries dbcc once. But by default, it is disabled, and it is really recommended to enable this to be able to benefit this faster execution times. But to be able to use it, the query has to be exactly the same as the one that was cached. Otherwise, it will not work. Also, if your query is non-deterministic, meaning that with every execution it returns a different data, it will not be cached. And example of a non-deterministic query might be the one if you use getDate in your query. So it returns a current time. So every time you run it, it will return a slightly different values. So those queries will not be cached. All right, so that was the second cool thing about SQL Pool. So let's move on to partitioning. And I know that partitioning was covered so far. It has different meanings depending on a service. So let's see how it looks like in case of SQL Pool. So partitioning. All right, so let's talk about this one. And actually, partitioning in SQL is not a concept created for SQL Pool. No, it exists. It existed for many years in SQL Server on premises. And basically, partitioning is a way to improve maintenance of your queries. And as a side effect, it also might improve query performance in some cases. So what is this partitioning? So basically, when you are creating a table in your dedicated SQL pool, you might partition it by some column. It would result in splitting it logically into those partitions on which later we can execute some operations that will be beneficial to us. And now partitioning is transparent to end users. They even don't know that partitioning is enabled. The same with distribution. It is hidden in internals of SQL Pool. Alright, so when to use this partitioning stuff? And basically, its main goal, main use case is for maintenance. So imagine a case that you have a big table in data warehousing. It is usually a fact table. You are partitioning fact tables rather not dimensions. And maybe your business logic is that you have to keep your facts for 3 years only. Older data can be removed. So So every month, what you would do would be to remove data from the oldest month, just to make place for new data. And obviously you could do this in a good old way using delete statement, delete from table where some predicate. It would work. But the thing is that, well, it will take time. Remember that this fact table is probably big. It will take time, it will create logs on your table, and it might degrade the overall performance of your database. And by using partitioning, it can be done much faster. So actually, let me draw how this scenario might look like. So again, yet another rectangle. I told you that there would be a lot of rectangles today. So let's say that this is our big fact table. And later on we'll get back to the part what big means, when it is beneficial to use partitioning in the first place. And let's say that, well, we would like to partition it based on some column. And in 99% of cases, you use a date column for partitioning. So let's assume that we did exactly this. We partition our fact table based on a sale date, or whatever date there is. And we created partitions by month. So in our oldest partition, let's say we have data from January 2021. In the second partition, we've got data from February 2021. Then we've got from March 2021, and so on. And in the newest partition, we have some data as well. And now, let's assume that right now, we would like to get rid of this data from January 2021, because we no longer need this. And we know that, well, this delete statement, it will take too much time, so we would like to use this partitioning stuff. So let's assume that our table has been partitioned already, and to implement this scenario, it is called sliding window. When we have a sliding window of data of particular range, in our case 3 years, it would look like this. So we would create yet another table that would be empty table. Its schema, its structure would be exactly the same as the structure of our big fact table. And as a first step, what we would do would be to switch partitions. That's the first type of operation we can do on partitioned tables. So we would switch them. Switch partitions. And we would basically switch our whole table, the empty one, with data with the first partition from our table. And what would it effectively mean would be like this. Data from our partition would be magically moved to the other table. Just like this. It is a metadata operation. It is super fast. There is no blocking at all. So suddenly, data from January would disappear from our table. We just removed this in a matter of seconds. So that's the first thing you would do. Switch partitions. Then you would probably want to remove this data from this new table that was empty previously. It is not empty right now. So you would remove data from it. But here, because it is a separate table, it will not block an operation that is executed on the big table. This is fine. You could even truncate the table. It is completely fine. So it would be fast. That's great, but, well, we removed the old data, but we have to make place for data for a new month, right? And yes, we would do this. So as a third operation, we would split partition that exists as the newest partition, and we'll simply add a new range in it for a new month. Let's say for July 2024 or whatever a range is necessary. And finally, what we would do, well, this place is empty and we don't need it anymore. So let's remove this. So as a last step, we would merge those two partitions together, which simply means that we would effectively remove this boundary. So it would become a single partition, and we would repeat the process every month. So our window would just slide over time. That's why it is called a sliding window scenario. And actually, it is so common case that you can find scripts, TSQL scripts in the internet that do actually this, exactly this. Just switch the partition, remove data, split partitions, split ranges, and merge partitions. So it is just to be configured and then used. And here partitioning is beneficial because it makes this removal operation very fast. There are no logs used basically at all, so you could still query the data without any issues. Now, the second benefit from the partitioning is that, well, if we have queries that filter the data based on date, for example, on a date that was used to partition the data, then our query optimizer would know which partition it has to read. So it would be just faster. So that's how it works. Now, when it comes to best practices about partitioning, well, the first important thing is, all right, so which tables you would like to partition? So obviously the big ones. And the big ones are facts. So you would partition your fact tables, not dimensions. Secondly, all right, so how many partitions should I have? 1,000? No, it's probably not a good idea. If you have 1,000 partitions, then probably you mess it up. Don't create a partition for every day. No. And the guideline from Microsoft is that you should have less than 100 partitions. So don't go crazy with creating them. All right, but we know that in case of those big fact tables in SQL pools, we would index them using clustered column store index, because that's the type of the index that gives many benefits to our analytical queries. So again, are there any guidelines how to partition those tables? And actually they are. So let me draw it again. Yet another rectangle. Or square, more or less. So let's assume that this is our fact table, because we want to partition fact tables. Don't do this for dimensions. There is no point of doing this, usually. And now, you should remember that in case of SQL pools, dedicated ones, our data is distributed into those 60 distributions, always. Obviously, we can have impact on the way how data is distributed, but it will always be split into those 60 parts. So those green bars are our 60 distributions. Now, apart from those distributions, we can partition our data, and it is done independently from distributions. So let's say that those purple things are our partitions. And now the guideline from Microsoft is like this, that the part that I just highlighted, that is a combination of partition per distribution, well, to benefit from our column store index, it has to have at least 1 million rows. So this part here, 1 million rows, to benefit from the column store index, to compress it, to close the row groups, or however it is called. So that it should give you a hint how big your table should be to even consider partitioning. Because maybe if your table is not that big, then you wouldn't benefit from partitioning at all. So number of rows is one of the main criteria you should take into account when deciding about the number of partitions. Alright, so that's how it works, but then how do we actually partition our data? What's the syntax and how it works? So it works like this. So when you create a table, you use this create table statement. That's obvious, right? So let's do this. Create table, and you would give it a name. You would set its definition, list of columns, data types, and so on. Then you would provide some options, like, for example, distribution, how this table should be distributed into those 60 distributions. So with distribution, equals to one of those methods. There are 3, right? And we know that in case of fact tables, we want to use hash distribution based on some column, whatever we believe is a good way to split the data. Let's say by customer ID, like so. All right. We might set some indexes, this clusters column store index, and the important part is that here you would also define this partitioning part. And to make this work, you would simply add partition and then indicate which column should be used for partitioning. For example, sale date. And usually you want to partition on the date column. So sale date, then arrange left or right, and in a second I will explain what it means. For now, let's assume right. Right. For values, and then you would provide a list of those boundary points. So for example, in our case, let's go like this: 20, 21, 01, 01, then 20, 21, 02, 01, and 20, 21, 03, 01. So let's define only 3 boundaries right now. And now, so what are those things? Well, these are simply those boundary points. And here I'm assuming that the syntax is like this: year, 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 month, month, and day, day. So the first value simply means the 1st of January. The second one is the 1st of February, and so on. And actually, those values here that you provide as those boundary points, they have to be values that are available in the column that you chose for partitioning. And usually, in case of data warehouses, you want those foreign keys to not have any business meaning. That's why you would use those surrogate identity keys like 1, 2, 3, and so on. But the only exception is date, because for dates, and this is a foreign key to a date row, usually you construct them in a specific way just to represent a specific date. And the benefit of this is that by looking at the ID, this key, you already know what value it represents. So it is very easy to automatically generate those values if you need them in future. For example, to create those new partitions for new months. All right, but actually, how does it look like on a diagram? How does it split our data? So let's assume that this is our timeline. And let's mark those points, those ones, on our timeline, on our data. So we've got 3 points. The first one was 21, 0101, so 1st of January. Then you've got 20, 21, 0201, 1st of February. And likewise, we've got 20, 21, 0301, 1st of March. And if we define our partitions in this way, it simply means we want to split the whole dates by using those points. So the first partition would be like this. It would be all data that falls within this range. So it would be from the beginning of the word till this 1st of January. So 20, 21, 01, 01. All right, but how about those rows that have sale date set to exactly this boundary point? Would it belong to the left partition or to the right partition? And that's exactly what this word determines. It might be either set to right or left. And it simply means, well, in case of right, and we use right, well, this boundary point, it belongs to the partition to the right. So the second partition would be like this. From the 1st of January to the 1st of March. If we used left word, then these rows with date equal to this boundary point, they would belong to the partition on the left. And so on, and so on. So in our case, by using those 3 boundary points, we defined 4 partitions. There is always one more partition than the number of boundary points. And simply that's how partitioning works. And in real life, well, in case of smaller tables, you don't have to bother with partitioning at all. Please remember about this recommendation, that this part should have at least 1 million of rows. So think twice before you start partitioning, because it might not give you any benefit, and actually it might degrade your performance, because if your table is not big enough, you will not benefit from the clustered column store index. Alright, so this was partitioning. And the last thing for today are some TSQL commands. So the first one, before I jump to portal, let's talk about pivoting and transforming the data. So let me write it down. Pivot and unpivot. Unpivot. So what is this all about? So let's assume that we have some data in our table. We have our minifix, and in minifix we have a column called type or minifig type, something like this. And we also have a column that determines how many parts a given minifig has. So let's say that type A has 10 parts, this row with type A. The second row of type B has 2 parts. The next row has 1 row, and again there's yet another row of type A that has 2 rows. And this is our table. Great. But what if we would like to transform it a bit and have it available with type values as columns, and in cells we would like to have a sum of parts. So it would look like this. We would have those A, B, and C columns as column names, and as values here we would like to have a sum of parts, obviously grouped by type. So in our case it will look like this. So for A we would simply sum this and this value, so it would be 12. For B it would be 1, for C it would be for B it would be 2, for C it would be 1. And the way to do this using TSQL queries is simply to use a pivot statement. And it is available not only in SQL Pool, but in SQL Server on premises as well. I've used pivot maybe once in my whole career and I can't remember the syntax, but it is possible. So maybe if you need to do this, pivot is there. The reverse operation, well, it is simply unpivot. Just like in Excel. You might compare it with these pivot tables in Excel. So that's how you can transform your data by pivoting columns with rows. And finally, let me jump back to Azure portal. And let me talk about 2 additional things. So first of all, we've got identity. So you know that in case of data warehouses, we often would like to have this surrogate key, this artificial ID that doesn't have any business value, maybe except for ID for dates, that would be used as a foreign key. And to automatically generate those values, well, you can use identity property on a column. So let me run this query. So let me first drop the table if I have it. No, I don't have it. And then let me create a new table called minifigs with ID, in which I have this new column called ID that is defined as integer with this identity 1 property. So it means, well, simply start from 1 and increment values by 1. And then have some distribution, some indexing without partitioning, because there's no point in doing this, for this table at least. So the table has been created. And then let's just insert some rows into this table. And please note that, well, I'm taking the data from our existing minifigs table, but I'm not providing any value for this ID column, because that's why we used identity property to automatically generate those values. So let me run this. It took 2 seconds. And then if I query this newly populated table, and if I sort this by our ID, you will see that indeed this ID column has been populated with those values, 1, 2, 3, and so on. So it is done automatically for us. So we can use this identity property in case of columns that we want to treat as those surrogate keys, those artificial IDs. Something similar we did in Databricks. So that was identity. And the last thing for today is data skew. So when I was talking about this hash distribution method, I told you that you should pay attention to data distribution. So for example, if you have rows, sales transactions, and 90% of sales is made by a specific customer, a single customer, then if you hash your data based on this column, you might have the very non-uniform distribution of data. So most of the data would land on a single partition, which means that the performance of your queries might suffer, because on the one distribution there will be way more data to be processed than on others. And the way to check if you have this data skew is to use this pdw show space used command. And actually take a look that it uses this pdw prefix. It is from old days when this product, SQL Pool, was called Parallel Data Warehouse. It was on premises many times ago. This product, it was renamed several times, and finally it landed as a part of SQL Pool. And if I run this for our minifix table, it will simply show me a number of rows available for every partition, for every distribution, sorry. So we have 60 rows in our results because that's how many distributions we have, and you can just see how many rows are on each of those distributions. So if you compare them, you will see if there are some that have way more data than the other ones. Alright, and that was it for today. So today I wanted to cover those extra features in SQL Pool, like workload management, that is all about reserving resources for your queries and setting how they should be processed in which order. Then we covered results set caching, is a way to, well, to improve performance of your queries, so they are taken from the cache instead of being executed every time. Then we talked about partitioning, which is about improving your maintenance, especially in case of this sliding window scenario. And finally, we talked about some SQL commands like pivot, identity, and this show space used command. So thanks for watching and see you next time. Take care.